have some kind of relationship? Because if they do, I know not of it. The weak nuclear force, the electromagnetic force, and the strong nuclear force can sort of be unified depending on the energy regime of it. But these three things have not been unified with gravitation, as far as I know. So gravitation being a force that is always attractive, it's much weaker than the electromagnetic force. That's true, but it's not the weak nuclear force. That's quite a different thing. And the weak nuclear force, by the way, the weak nuclear force and the bosons that carry the weak nuclear force, the W and Z bosons, those being discovered and all that stuff was a big deal. So again, those are sort of progresses in quantum mechanics and not giving us explanations in terms of GR or gravitation, really. Okay. So so generally, physicists are people who either study small things like quantum mechanics, or they study big things, heavy things like stars and galaxies and gravitation. Gravitation is mainly something that comes into play when there is a lot of mass, for example. And so it is very important when it comes to the stars and the galaxies. And we even found that there's this other extra thing called dark matter only because we can't really see it, but we see it interacting with gravitation. So we see the expansion of the universe and how there's sort of this anti-gravity going on in the universe, which helps it to expand against gravitation, and things get farther apart with time. So in those types of scales, gravitation is important, but in the quantum mechanics scales, we don't really have an explanation of gravitation. Gravity is the only thing keeping me down. Are you catching a flight, Doro? Is that why you're not going to be kept down? Or are you going to be on a balloon? I was asking because if gravitons are theoretical quantum particles and it's so much weaker in comparison to the other forces, how could we ever hope to measure them? I don't know. I don't know. Are you asking energy regime wise? Is it very much weaker or something? Thank you, Doro. So I have to think about that. I don't know. Yeah, I have to think about that. As far as I know, there's no... So you know how the electromagnetic force, the weak nuclear force, and the strong nuclear force kind of come into play in different energy regimes? And so there's sort of a way to unify them. But as far as I know, there's not a way to unify these three that I just mentioned with gravitation. And that's really the challenge, okay? Okay, so most people don't study both the large and the small types of physics. This means that they use only quantum mechanics